All right, in this video what we're going to go over is scales of measurement. Now a scale of measurement is really just a quick and dirty way to tell someone and to communicate what properties your measurement has. Will it tell you how much of something there is? In other words, is it quantitative? Or will it only tell you what it is, but not if it's bigger or smaller than something else, i.e., it's purely qualitative? So, there are actually 4 scales of measurement. The first one is nominal. Now, when we talk nominal, think names, because that's really all we're talking about here is names of categories. There is nothing quantitative about this. It is purely qualitative. It will tell you what something is, and that's it. So examples of nominal variables are things like biological sex, race, ethnicity, political party. If someone is a biological male, well, they're no more or less biologically male than the next biological male. If someone is transsexual, they are not more or less transsexual than the other individual. Okay? So just what is the category? The next one is ordinal. So ordinal specifically refers to the order of things. So we start to now bring in quantitative elements to it. It will start to tell you how much. However, ordinal scales of measurement don't have equal unit size. Now that's kind of abstract. So really what you should think about ordinal is it's the rank. So a really good example is the order in which runners or cars finish a race. You have first place, second place, third place. You know which one was the fastest, but you do not actually know from the information I've given you how much faster first place was relative to second place or even to third place. It could have been a nail biter of a race where first and second were neck and neck and first won out by the slightest of margins. Or it could be like Secretariat was, wherein there is a massive lead over the person in second place, and it's not a competition at all. With an ordinal scale of measurement, you can't differentiate between these two things. It is purely the rank and the order in which scores are on a scale. The next scale of measurement is an interval scale of measurement. Now, for an interval scale of measurement, we still have that quantitative property here. And indeed, we're actually getting more quantitative description because now we have equal unit size. The distance between 1 and 2 on a number line is the same as the distance between 3 and 4. This lets you know how different two things are on a quantitative element. So a really great example of this is temperature in Fahrenheit. Okay? So it could be 10 degrees outside, and if it increases from 10 degrees to 20 degrees, you know that that's the same increase in temperature as, say, from 30 degrees to 40 degrees. It is 10 degrees hotter. There is no if, ands, or buts. You know precisely how much hotter one temperature is relative to the other. Okay? The problem with interval is you have no meaningful 0 point. Now, what exactly does that mean, a meaningful 0 point? A 0 point is meaningful if it indicates the absence of a zero. The absence of a variable. Nip, nada, nothing. Okay? So, 0 degrees Fahrenheit does not mean an absence of temperature. It really kind of means nothing. It's just an arbitrary point on a number line. Okay? If we have a meaningful 0 point, then we have ratio data. So here we have this quantitative property again, but now 0 means the absence of something. Bob has 0 kids. 0 means no kids, not some arbitrary point, okay? If, and this is why we make the distinction, Bob were to have a kid and have 1 kid, and then have a second kid, now we can also say that the number of kids that Bob had when he goes from 1 to 2 has doubled. We can use a ratio now, hence the name ratio data. So, to sum, when we're talking nominal data, all it is names and categories. Republican, Democrat, Libertarian, Green Party, so on and so forth. Just names and categories. Ordinal, we're talking ranked data. We know which has the most and we know which has the least, but we don't exactly know how big the difference is between the most and the least. Interval, we have even more quantitative description here. We know exactly how much of something there is, but 0 doesn't mean anything. It's just arbitrary. And then when we have ratio, where we have both that equal unit size, but also a meaningful 0 point. They completed 0 problems correctly. They had 0 kids. It means an absence. All right, I hope that helps. If not, hit me up with questions. Have a good one.